So now we saw how sliding friction plays into. Let's add the rest of our forces in. So let's draw our free body diagram. When you push at 1 meter, if the radius of this wheel is 2 meters tall. So I push at 1 meter, so my radius right there in the middle, I'm going to push it half of that. So my force applied is here. Okay, what other forces are there? Well, I know the normal force is here. Normal force is perpendicular to the surface. I know gravity acts at the center of mass, so gravity's going downward. Again, now friction's there. Well, we just saw you have to decide which way is friction going to go. It can change. So if I looked at this, well, let's first see which one of these create torque before we even get to friction. Okay? Well, I know force normal, or the torque of the normal force equals 0. Okay? You could see that the force normal line goes through the axis of rotation. Anytime we do that, we know lever arm equals 0. Or you could say R is parallel to the force there. Okay? This is also mg is the same. Or with mg, the force, the R is 0. Okay? So kind of either way you could explain it. Now at this one, the lever arm, we could extend out that force line, axis of rotation down, so the difference between those two, that is the lever arm, this little spot there. So it has a lever arm, it has a perpendicular force. So with this one, force applied, there is a torque applied. It does not equal 0. So you have a torque applied because you have a perpendicular force, you have a lever arm, all kinds of different ways to look at that one. Okay. Now what's happening to friction? Well, we have to see what the force applied does. Well, like we did in the previous video, right, we saw that the force applied makes the ball or the wheel accelerate to the right and angularly accelerate counterclockwise. Now these two are not going together, so this would be something slipping or this would be something having backspin. So now what we have to look at is we got to figure out, well, friction says, oh heck no, there's no slipping going on in my house, so we got to fix this. So in this case, we're going to say to the right is positive, so the acceleration is positive, and the rotation is opposite of that, so that is negative. So a positive is bigger than a negative. So friction is going to balance this out, so it's going to decrease the acceleration and therefore also increase the angular acceleration in the positive direction. The object is being pushed to the right, so the acceleration is to the right. So to decrease that, force of friction has to be going to the left. Okay. Now, how do I know friction creates a torque? Well, again, the force is perpendicular to R, or it has a lever arm, whatever you have there. So this is the forces that are going on in this scenario if you pushed at 1 meter. Now, let's go down here and look at the next question. If you push at 2 meters. Right? Maybe pause it as I'm erasing these and test it out for yourself. Do the exact same thing and see what you could come up with. Right? Then I'm going to go over it. Right? So now, let's draw our forces back in here. Again, I'm pushing directly in the center. Right? Gravity acts at the center of mass. Normal force is perpendicular to the surface. But again, friction will have to decide. Now, force normal, gravity are still the same. Torque is 0. Because they both go through the axis of rotation. Okay? Now, torque done by the applied force, that also equals 0 because force goes through the axis of rotation. Again, if you want to talk about lever arm, you could say lever arm is 0. Okay? So now, what does the force applied do? The force applied causes a positive or rightward acceleration, and the alpha is 0. Well, wait a minute. Friction doesn't like that. Friction says, well, wait a minute, my equation is not balanced. Okay? So it's saying that the linear acceleration, is greater than the angular acceleration. So it's going to have to decrease linear acceleration and increase angular acceleration. So if the force is to the right, how can I decrease that? I can have friction going the opposite way. And then friction is also going to give you some clockwise rotation, which is in the direction of most it's supposed to go. So that again is increasing alpha and decreasing A. All right, again, pause it on the next one, and let's try what you can come up with on the last one. All right, our last example is what happens if you push at 3.5. So not quite the top, so let's say you push here. Again, normal force, which is perpendicular to surface, goes through the axis of rotation. Gravity goes through the axis of rotation, does nothing, but we have to find out what does the force applied do. Well, force applied, okay, causes a positive linear acceleration and a positive alpha. We're saying to the right or clockwise is positive. These are both in the same direction. So friction's not really sure what to think about this, because if we looked at our equation, okay, we have alpha times r equals A, and this side is positive and so is this side. So it could be balanced. You may not even need friction. So then it depends, well, how hard am I pushing? And how high up am I pushing? Because if you notice, this is my axis of rotation. There's the force origin, so that is my lever arm, or my R. Okay? So I have a certain amount of torque. If you push with great enough force, you may have a bigger acceleration compared to your alpha, and that could be the same thing we've seen before. But what if you push too hard and then alpha is now too big? Okay? So this is the one that's different from the previous one. If you push too hard, well, let's see. Well, friction has to decrease this and increase this. So which way is friction going to go? Force applied is going to the right, but I need a bigger acceleration. Well, I need a bigger force, so friction could go this way. And then it's also, we saw here, decreasing this, so we're rotating back the other way. Okay. So on that one, friction could go, and it's going to take more complicated scenario to find out which way friction is going. It could be either way. It just depends on how much you push. And that's what we'll look at in class. Okay. Write some questions down, come to class with those questions, so we'll be ready to jump right into it. Hope you're having a great day off on Monday.